I think we have done with DNA and DNA protein synthesis as well as application.
We were doing redox reactions.
Okay, we were doing redox reactions. You wanted, okay, fine.
I was gonna ask if we could do like salt, bases, and acids today.
Bases and acids.
Yeah.
Okay, fine. I'll do that for you. Okay. Do you want acids and bases or do you want acids and alkalis?
Um. Both.
Do you want acids and or acids and alkalis?
Oh, acids and bases, please.
Acids and bases. Okay. Basically, there is nothing much difference between an alkali and bases. Okay.
Mm-hmm.
See both of them. Okay. Which level do you are you in? Like, are you doing GCSE A level or AQA?
OCR A level.
OCR A level. Okay, fine. That means I have to teach you something in detail. Okay. Now, first what we'll do is we'll get some basic things about acids and bases. Okay.
Uh-huh.
Now, acids are compounds that dissolve in water to produce hydrogen ions. So, first part, what I'll do is I'll put all the acids here and I'll put the bases over here. Okay.
Yeah.
Okay. Acids. As I was telling you, acids are the compounds that dissolve in water. And what do they form? They form hydrogen ions. Okay, hydrogen ions
Mm-hmm.
are represented as H plus. Okay, then some of the acids like HCl, that is hydrochloric acid, sulfuric acid, and nitric acid. Okay, hydrochloric acid, sulfuric acid, and nitric acid, they are considered as strong acids. Okay, then if these are strong acids, what is a weak acid? Weak acid, we have an example of ethanoic acid. This is a weak acid. Okay, and
Mm-hmm.
my pH scale gives me a numeric value that measures from 0 to 0 to less than 7, just as 6. So this will be acids. Okay, pH
Yep.
ranging from 0 to 6 will give me acids. Okay, so these are general basic things about acids. Moving on to bases. Now they dissolve in water and form hydrogen ions, while bases they again dissolve in water and they form hydroxide, that is OH minus. Fine.
Mm-hmm.
That a base is a substance, okay, a base is a substance that reacts with an acid. I'll write that. Base is a substance that reacts with an acid and produces a salt plus water. Okay? Always remember, talking about bases, they react with an acid to form salt and water. Okay? Here we saw these are the strong acids, right?
Yeah.
Okay. Here we do not, we will see some of them, but before them, some other information about bases is that, what can I say? Okay, they form hydroxide ions, then they form salts. Okay, sodium hydroxide, NaOH, and potassium hydroxide. Sodium hydroxide and potassium hydroxide, they are the strong alkalis. Okay, then okay, I think this much is enough. Then pH ranging from more than 7, that is starting from 8 to 14, they come under bases. So if you see it is 0 to 6, 7, 8 to 7, 14, and 7 becomes neutral value, that is pH 7 is my neutral value. Okay.
Uh-huh.
Now when I was talking the thing that bases react with acids to form salt and water, right? We will see
Mm-hmm.
few of them. So what is happening? Sulfuric acid, okay, sulfuric acid is reacting with the base. So sulfuric acid forms salt called as sulfates, okay, when we are getting salt and water. Sulfuric acid, when reacted, we get sulfates. Hydrochloric, hydrochloric acid forms chlorides. Nitric acid will give us nitrates. Okay, and ethanoic acid will give us ethonates. Okay, you understood this part?
Yep. I'm just writing it down.
Yes, write it down.
Yep.
Okay. Okay. You are done with that part?
Yes, thank you.
Okay. So if you have understood this, then I'm going to give you a few questions to solve. We'll do revision wise. We'll do some topics, we'll do a revision questions, okay?
Mm-hmm.
These are the questions. If you want, you can answer it only, or you can put it on your book as well.
Okay. How will I know which one is the weakest?
I just told you few of them, right?
Oh yeah, yeah.
Given you anything out of the box.
Yep, I've done all the questions.
You're done with the questions.
Yeah.
Okay, good. Can you give me the answers then?
Yeah, so it's sulfuric acid, hydrochloric acid,
Okay.
and acetic acid, ACETIC.
This one, last one.
Yeah.
Okay.
And the last one's the weakest one.
Which was gonna weak acid? That is the acetic one, right?
Yeah.
Okay.
NaOH and KOH are the two alkalis.
Okay.
Copper sulfate is made for 2B, and magnesium chloride is made for 2C.
Very good.
For 3A, D. For 3B, it's E.
Okay.
For 3C, it's C. For 3D, it's A.
3D is a
A.
A. Okay.
No, the second one is E, and then the last one's B.
This is E, right?
Yeah, and then the last one's B.
B. Okay. Perfect. So you understood the basic concept of acids and bases?
Yeah.
Okay. Fine. Now going into more detail. We just saw that acids, they form acidic solutions. What acids they form? Acidic solutions when they are in water. So what happens? They produce this H plus ions, okay? That means HCl when in aqueous they give H plus Cl minus, okay? And here my pH range is less than 7.
Less than 7.
Then comes the alkalis. They form alkaline solution in water. Okay, and they are the sources of hydroxide ions. That is, if I take an example of NaOH, which is an aqueous solution, it gives me Na plus plus OH minus, right? And here my pH is more than 7. Then what I have is my neutral solutions. Now neutral solutions, they are neither acidic or basic, right? Basic, or we can say they are alkaline. And here my pH will be equal to 7. Okay, so we have acid,
Yeah.
alkaline, and neutral solutions. This I think we have seen earlier also. Okay, shall I move to the next page, please? Next slide.
1 second.
Yeah, okay.
Yeah.
Okay, fine. Now, what if I give a solution okay, and I ask you to find out which one is acid and which one is alkali. So I have two different solutions. Okay, I ask you
Yeah.
which one is acid, which one is alkali, or which one is a base, I mean a neutral one. How will you find it out?
Um, reactions.
Directly you'll go for reactions.
Like if you test them both with acids, one will react, one won't.
Okay, for this, what we have, they are known as indicators. Okay, we have specific indicators to help us find out the acids, bases, and the neutral solutions. Okay, so first indicator we'll see is about the litmus paper. Have you heard about litmus paper?
Yeah.
Okay, so what do you know about litmus paper?
Is it just like it's like it's a pH indicator?
It's not pH indicator. What did I say? These are normal indicators only used to distinguish between the acids, alkalis, and the neutral solutions. Okay. Now, basically, we have two kinds of litmus paper, one a red and one a blue one. Okay. These are just normal paper strips. Okay. A one red and one blue one. Now,
Yeah.
the test for litmus paper, whenever when we have an acid solution, my litmus paper will be red. When I have a alkaline solution, my litmus paper will be blue, and when it is neutral, it will be purple. Okay, so acid it will be red, alkaline it will be blue, neutral it will be purple. How can we find out this? Now, if these are two different solutions, okay, this is an acidic solution and this is a base or an alkaline solution. What I'm going to do is I'm going to take a strip of this red color litmus paper and I am going to dip this acid solution. Now the litmus paper is red color itself, right? So even if I dip it in acid, it will still show me red. That means there is no color change. If I dip my blue color litmus paper inside my acid, what color it will change to?
Blue.
Red. My blue litmus paper will turn red in acid.
Oh, sorry, I thought you said alkali.
Okay. So when
Yeah.
I'm putting it in acid, my any litmus paper, red or blue, it will be red color. If it is a base,
Yeah.
if any of my solutions is a base and I dip any of my litmus paper in any of the solutions, it will be blue in color. Okay, so red might change into blue when in base and blue will remain blue if it is in alkaline solution. Clear? And if the
Yeah.
solution is neutral, it will show as a purple color. Clear?
Uh-huh.
Okay, so this was a litmus paper test. Second indicator we have is about methyl orange. Okay, now methyl orange is a liquid where we use them as a indicator. So if it is an acid, it will show again red color. If it is an alkaline, it will show yellow color. If it is neutral, again it will show me yellow color. Okay, so this is about methyl orange. Last, I have my indicator as phenolphthalein. Again, if it is acidic in nature, it will be colorless. If it is alkaline, it will be pink. If it is neutral, it is again colorless. Okay,
Mm-hmm.
so you got the indicators. Now
Yeah,
methyl
I'm just
is
this
bright
one.
orange in color. So whenever we add an acid to it, it will turn into red. Or and if it is an alkaline or neutral solution, it will turn into yellow. Okay. Phenolphthalein,
Yeah.
it is light blue in color. If it is an acid, it will turn colorless. If it is an alkaline, it will turn pink. Or if it is a neutral, it will turn colorless again. Okay.
Mm-hmm.
Tell me if you're finished writing it down, and then I'll move on to the next one.
Yeah.
You're done?
Yeah.
Okay. So this was indicator which is used to differentiate between acids, alkalis and neutral solutions, right? Okay. Now we have identified solution A as an acid. If suppose, okay, just imagine we have identified A as acid. I'm asking you if acid, tell me the pH value of it. How much is the pH value of this solution? How will you tell me?
Are we gonna use a universal indicator?
Yes, and what is that universal indicator?
Um, it's just I'm not sure how to describe it.
Okay, so universal indicator is nothing but a chemical solution that produces many different color changes, color change, okay, to different pH levels. This is an universal indicator, okay. So what we'll have is once it changes the color, we have a small graph, no, no, not graph exactly, a pH scale depending upon the color. So we have, since we have 14 pH values, we have to divide this into 14. How much is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14, right? Okay. So this will be my universal indicator colors, starting with red, shades of red. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it will be shades of red starting here. As it reaches 4, it will turn into orange, some yellowish, light green, and here it will be green, bright green over here. Then it will start decreasing the colors from light blue to darker shades of blue. Okay, so here
Yeah.
the color representing acids, here the color representing will be the alkalis.
Yeah.
Okay,
Mm-hmm.
fine till here. So we have indicator to tell us whether they are acids, alkalis or neutral, and we have this pH scale to find out which exact pH they belong to. Shall we move on now? Done writing?
Yes.
Okay.
Yeah.
Next, we'll see few reactions of acids. Now, acids, they take part in reactions in which salts are produced. So whenever we are reacting acids with anything, my product will be a salt. Okay, and this salt is formed by replacing the hydrogen ions. So my product form is a salt, and it is a replacement of hydrogen ions. Okay, replacement of hydrogen ions. Now we'll see a few examples of it or how the reaction is happening. Okay, first reaction see is reaction with metals. Okay, now reaction with metals. In general, whenever an acid is reacting with a metal, what we form is, as I said, we are going to get a salt, okay, along with hydrogen. So if I had to put a perfect salt and a metal, let me take hydrochloric acid plus metal, I'll take a magnesium, which is giving me magnesium chloride plus hydrogen.
Mm-hmm.
Tell me whether this reaction is balanced or not.
No.
No? Okay. Then
You need to put two in front of the HCl of the hydrochloric acid.
what should I put?
A number 2.
A 2. This is enough.
Yeah.
Now is it balanced?
Yeah.
Okay, fine. So this is a reaction with a metal. That means my acid, that is hydrochloric acid, is reacting with magnesium to form me magnesium chloride and hydrogen.
Yeah.
Okay. Now next reaction of acids is with metal oxides. Now, a salt and water, whenever we are reacting an acid with a metal, what we get is a salt and a water. Okay? Why? Because metal oxides, they are bases. Okay? Metal oxides are bases and they neutralize the acids. So, in general, if I had to write, it would be acid plus metal oxide giving me a salt plus water. Now I'm going to use this sulfuric acid with a metal oxide. So I'm using copper oxide. What am I getting is copper sulfate with water. Okay. Now tell me whether this is balanced or not.
Yeah.
This is balanced, so I don't have to add or remove anything.
No.
Okay, fine. So this is my reaction with metal oxides. Okay.
Mm-hmm.
We saw two reactions. My third reaction will be with metal hydroxides. Okay, with metal hydroxides. Again, metal hydroxides, they are bases. Okay, and we get
Mm-hmm.
same product over here as well. That means acid when reacted with metal hydroxide will give me salt plus water. That is, for example, if I am reacting nitric acid with sodium hydroxide, I will be getting sodium nitrate plus water.
Yeah.
Now, whether this is balanced or not, check.
Uh, yeah.
They are balanced.
Mm-hmm.
Okay. So, third we saw. Moving on, next fourth reaction is reaction with carbonates. Okay, reaction with carbonates. Now, earlier we had only two products, a salt, a hydrogen salt and water. But now what products are we getting is we get a salt, we get a water and we get a carbon dioxide because we are dealing with carbonates. Okay, so general
Mm-hmm.
reaction will be acid plus carbonate giving me salt plus water plus carbon dioxide. And example is I will take HCl reacting with copper carbonate giving me copper chloride with water with carbon dioxide. Okay, now tell me
Yep.
if this is balanced or not.
1 second. You need to add a 2 in front of the hydrochloric acid.
Yeah.
Yeah.
Okay, anything else?
No.
No. Okay, fine. So what did we observe here was we saw four reactions of acids with metals, with metal oxides, with metal hydroxides and carbonates, right? Carbonates.
Yeah.
And metal oxides and metal hydroxides gave us very similar products.
Yeah.
Okay? So clear with the reactions of acids over here?
Yeah, I've written it down.
You have written it down? So these were reactions of acids. Are you clear from everything we have done from the starting?
Yeah.
Okay. Next we'll see is water neutralization. Now, Neutral, what did we see? That they are either acidic or basic. Okay. And what is the
Mhm.
pH level?
Between 8 and 40. No, 7.
Okay. pH is 7. Then what is the difference between a base and an alkali?
Um, I thought they were the same thing.
Same thing, but why two different names if they are same thing?
No, I thought they were the same thing.
Okay. Now, a base is a substance that reacts with an acid to form salt and water. You remember we saw this earlier, right?
Mm-hmm.
So base reacts with an acid to form salt and water only. That means all my metal oxides and my metal hydroxides, they are all bases. Okay. Then
Yeah.
bases which are soluble in water are called alkalis. Okay, basically they are somewhat same, but these are the bases which are soluble in water, and bases here they react with acids to form salt and water. Okay,
Okay.
we'll see one example, then you will understand better. Now, if I give you an example of copper oxide, okay. Now, according to you, what is
Mm-hmm.
copper oxide? Whether is it a base or an alkali?
Um, it is a base.
It is a base. Okay, but is it also an alkali?
Um, no.
Why is it not an alkali?
Um, because it's not soluble in water.
Very good, because it is insoluble in water. Okay, and therefore it is not an alkali. Okay, then sodium hydroxide,
It is both.
both,
No, it is a base
it is a base. And why not an alkali?
because it's not insoluble in water.
Sodium hydroxide is soluble in water,
Oh, so would it be both?
both. Okay, it is a base as well as an alkali. Okay, only because NaOH is soluble in water.
Yeah.
Okay.
Mm-hmm. Yep.
Okay.
Mm-hmm.
Now we have only little time left. Okay, I'll just tell you what is a neutralization reaction. We saw that neutralization, it's neither acidic nor basic, right? And
Yeah.
acids, they produce hydrogen ions, bases, they produce hydroxide ions. Now, when we're talking about neutralization, what kind of equation we will be getting? Okay, we'll see that. if I am reacting a acid HCl with a base NaOH, okay, what will I get is NaCl plus
H2O.
H2O. Okay, that means I'm getting a salt and a water. Okay, clear with this? HCl plus NaOH giving me NaCl plus H2O. So what I've reacted here is I have reacted an acid with an base. Okay, and if I had to split it down and write, it will be H plus plus Cl minus plus Na plus
O minus.
yeah, sorry, which is going to give me Na plus plus Cl minus plus H2 since it is a liquid over here. Okay, now in this case we do not need chlorine and sodium ions, so simply I can put it as H plus plus and sorry, H plus okay.
Mm-hmm.
Any doubt till here?
So just together they neutralize each other.
Yes. So we know that water is neutral, right? Water
Mm-hmm.
neutral. A neutral solution they can be produced if the correct amounts of the acid and this alkali they react together.
Yeah.
So if I had to define neutralization, this will be okay. So I was supposed to write the definition, right?
Yeah.
Acid, alkali, neutralization. Neutralization is a reaction
Did that say hydrogen?
Yes, I don't know. One moment. So an acid alkali neutralization is the reaction between hydrogen ions and hydroxide ions forming water. Okay?
Yeah.
Okay.
Mm-hmm.
Now tell me whether you have any doubt of whatever we have done today.
No, I understand all of it. Thank you.
Yes? These were the simple ones. You understood everything here?
Yeah.
Then I think we can conclude over here, right? The topic on acids and bases is not yet completed because we have to still do on pieces. We have just finished with acids, okay? The rest
Uh huh.
we can continue in our next class.
Okay.
Okay? Thank you.
Yeah.